So we have the lower 5 statements about the graph. What's the key thing we have to do whenever we get an equation? Always make sure our factor out the b every single time, or else our c will be wrong, right? Our stretches will always be right, our reflections will always be right, our vertical translation will be fine, but our horizontal translation or horizontal phase shift will be wrong every single time if you forget to take it out. So we're going to get f of x equals negative 6 sine 1/2. When we divide by a half, it's like multiplying by 2, so we get 2 pi plus 10. Remember, when you divide by a half, it's like multiplying by 2, right? So, the period of the graph is 4 pi. Well, it was originally 2 pi. I'm now stretching it by a factor of 2, so it should be 4. We agree? 4 pi. Just based off even the horizontal stretch factor. If you don't use that, you can go 2 pi divided by b. b is a half, which is 4 pi. Still true. So you can use your reasoning of if it's a horizontal stretch by a factor of 2, it's going to double it. Or you can use the formula. The y-intercept of the graph of f of x is 4. Y-intercept means what x is 0, right? So we can go y equals negative 6, 1/2, 0 plus pi. I'm just putting it to the original. Plus 10. And there's a sign in there. Oops. Y equals negative 6 sine pi plus 10. What's sine of pi? What's y at pi?
0.
0. 6 times 0 plus 10. Y equals 10.
What about the 1/2?
1/2 times 0.
Oh,
Right? It's going to go away. I plugged it right into the original just because it's easier than plugging it into that one. Yeah.
You could just look at the b value as well, like with that work, or is that not the rule?
No, you have, because there's a bracket in there, you could end up not getting 0 there, right?
Oh, okay.
Now, if you think about it, if the midline is at 10 and I go up 6 and I go down 6, then I have to watch my shift as well, right? Yeah. So you just plug 0 in for x and just use your normal trig ratios after your unit circle and stuff like that. So it would be 10. So this is not good. The y-intercept is actually 0, 10. Whenever you hear y-intercept, you should always think x equals 0. Solve for y every single time. The amplitude of the graph, can the amplitude be negative? Amplitude is a distance, so I don't even care what that says. It has a negative. It's totally wrong. But the amplitude actually would be the absolute value of negative 6, which is 6. So that's wrong. Statement 4, the graph of 4 cos, I got to pull that out of there. 4 cos 2 x minus pi over 2, because you have to take out a 2, which is division of 2, plus 12, has the same maximum. I actually didn't need to do any of that. Because maximum, how do I find a maximum? D plus amplitude. So the max for this one is 12 plus 4, which is 16. What's the maximum for this one? Yeah, 10 plus 6, which is 16. Boom. If I know my rule of D plus A, it's a very fast question. Right? If not, you're typing in your calculator doing some weird, crazy stuff.
Or if you do the first 3, you just know it.
No. No.
Yeah.
Bad. Okay. The graph of f of x is the same as the graph of h of x equals negative 6 sine 1/2 x plus 10 if h of x is translated 2 pi units to the left. Okay, what is this? 2 pi units to the
Left.
left. So it's good. The 3 statements above that are correct because we actually proved that they're correct are 1, 4, and 5. Now you could put these out of order actually because it doesn't say what respectively or low to high or anything like that. I don't rebel. I just go low to high all the time. Like I'm not a rebel without a cause. Like I want to put them out of order. So I just put them in order. Okay. Name the amplitude, period, phase shift, and displacement of each. What's the amplitude of this one? 2/3 because it's the absolute value of A. What's the amplitude of this one? 2 because it's the absolute value of A. Shh. The period of this one is going to be 2 pi divided by B, which is 1/4. Or I know, hey, it's a horizontal stretch of 4, so it's going to multiply by 4, which is going to actually make it be 8 pi. That's why you end up multiplying by 4, right? The period of this one is 2 pi. I'm going to multiply it by a horizontal stretch of 1/3, or I'm just going to divide by the b value. Either way, I get 2 pi over 3, right? If I multiply by 1/3, it's the same. Divide by b, it's the same. Horizontal phase shift. This one is going to be pi over 12 units right. And then this one, I have to take the 3 out first. I get x plus pi divided by 3. So this one's pi over 3 units. Where? Left. This one is a vertical displacement, 3 units up. And this one is a vertical displacement, 4 units down. Then the question that hurts brains. Okay, but your brains are strong, big brains, so you won't find this that hard. How do I get the A of every equation from off of a graph? Yeah. So what we can do is we could literally count it. So we could go -3 to 1 is how many? 4, right? And half of that is 2. We could do that. Or we can go absolute value of max minus min divided by 2, which would be absolute value of 1 minus a -3 divided by 2, which is 4 divided by 2, which is 2. Or half the distance from the min to max, 2. All of them are A's. Great thing, right? Okay, so I know that I have y equals 2. Y equals, we're going to practice both. +2, -2, because we're rebels without a cause. So we're going to show every single version. Except when we go to the test, we just rock it. Okay? Then I'm going to go, oh, look at this. There's cosine down here too. Y equals 2. Y equals -2. Right? And then sine, sine, cos, cos. How do I get B? B equals 2 pi divided by what?
Period.
The period. What's the period of this graph? I'm going to start here. Past to max. Past to min. Back to the height. Takes me 4 to get to pi. 4 more to get to 2 pi. Well, isn't this the nicest one ever? If the period is 2 pi, what's my B? 1. It didn't stretch. She's nice. You're welcome. I didn't make this quiz. It has Mrs. Skier's name written at the top of it. It's pretty much a dead giveaway. It was not me. But that's nice. 1. So, B equals 2 pi divided by blah, 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 divided by the period. I can't say divided by. 1. Oh, look at this. 1, 1, 1, 1. Oh, I'm just so good at this. Look at this going. This is going good. We're not going to touch the C's till the end because those are like the devil's magic. But we're going to do those later. Just kidding. They're nice. Okay, D, midline. Where does that bad boy happen at? -1. We can either count down the amplitude and count up the amplitude, which is 2 and 2, and they meet at y equals -1. Or we can use the formula. D is max plus min divided by 2 because it's the average. So it's going to be 1 plus -3 divided by 2, which is -2 divided by 2, which is -1, same thing. And we draw our midline because our midline gets us our C values of sine graphs, right? The midline gets our C values of sine graphs. So it's -1. It's the line that cuts the graph in half. -1, -1, -1, -1. So it doesn't matter which I ask you to find. Boom, 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 boom. A, B, and D are all the same, right? It's C that's life-changing. Okay. So when I asked you if it was a sine, I told you to draw the midline and then bold the intersections with the midline closest to the y, right? So this one is closest to the y, but the arrow is going up. And then these are closest to the y, but the arrow is going down. So the arrow going up intersection counts for which one? Positive sign, and it's on the y. I'm done. We moved nowhere. It's still on the y-axis, correct? For negative sign, which one's better? Negative pi or positive pi? Whichever one matches the answer on the test is better. That's it. Neither of them is actually better, right? So if this is an open-ended question, you could give me one or the other and you would be correct. So you could have went x minus pi, going pi to the right, or you could have given the same question x plus pi and went pi to the left, and I couldn't deduct you marks. Unless I gave you the equation like x plus c, and then I'd be forcing you to go to the left, right? Now cos. Cos is our friend. Cos is easier to find. So for positive cos, I look for the closest what? Maximum. If 4 lines is pi, 2 lines is half of that, correct? So it'd be pi over 2. And which way did I go? Right. So I'm going to have x minus pi over 2. Now this one, my closest, min, which goes with what? Negative cos. It's halfway, so it would be at negative pi over 2. So I usually am at the y-axis. I'm now over at negative pi over 2. So which way did I move? Left. So I'm going to get x plus pi over 2. Okay? You have to know how to find all the different ones. We agree? All right. We're going to go back to our notes from yesterday. No. So this one here is written in a form, I told you guys to try this yesterday, in a form where the 1200 is sitting at the front, but if this is my option, I'm going to rewrite it to put the 1200 at the back so it's my d-value. Because it is my d-value, they just put it out of order of what I like. So I'm going to go r of t equals 300 sine pi t divided by 2 plus 1200. Where t is the number of years since 1970. So 1971, t would equal 1. 1980, t would equal 10. 1990, t would equal 20, right? So they're just saying after 1970 is what t is. So 1970, t would equal 0. If we wanted to know how many rodents there were in 1970, we have to put a 0 in for t, which we're technically just finding the y-intercept then. And r of t is the number of rodents. I didn't tell you what type of rodents, because I don't even know. And I actually don't care. I hate rodents. All right. So we want to find the maximum and minimum number of rodents, because who wouldn't want to, and the years at which this occurred in the first cycle. So let's figure out what kind of window we can make, because often people are really good at these in their calculators if they can get a window that works. But the window that works is the hard part. So we're going to do that. So we're going to find the maximum first. How do I get a maximum off of an equation? D plus A, the absolute value of A, right? Because it's the midline plus the amplitude. So I go 1200 plus 300, and I have 1500. Now my y maximum better be higher than that, correct? My y max has to be bigger than that. So I'm going to make it be 1600. So go to your calculator and make your y max be 1600, because you just figured out what it should be bigger than, right? So in your calculator, your y max is 1600. Then we go to our minimum. How the heck do we find our minimum? We do our midline, or our d value, minus our amplitude. So it's going to be 900. So if this is my calculator, I would make my y max be 1600. I would make my y min equal 900. And my y scale, I would make be 100. If it goes up by ones, you're going to have 900 to 1600 little 1 dashes. You're not going to see anything, right? Your y scale is just what each of those ticks is worth. If you want to be able to see the ticks, I'd make them worth 100 each. Okay, most people are okay with that. It's the x where it goes awry. Remember, you just want to be able to see, if you can see a period of the graph, then you can see one full revolution of this rodent situation, right? I always want to, I usually try and see 2, but it's up to you. So the way to get your x value, to find out what your x max should be, is I have to find the period of it first. So period equals 2 pi divided by what?
B.
B. And B is pi over 2. So it's 2 pi, technically, times 2 over pi. So it's 4. 4 what? 4 years this rodent population is cycling. Correct? Awesome. So I would make my x min. You could make your x min actually be, technically, in this case, negative. Because what would negative represent in this case then? The years before 1970. Now, if time was in seconds, could we make it be negative? No, we'd start at 0 because you can't have negative time. But if 1970 is year 0, if I ask you for 1950, you'd look at year negative 20, right? Technically, to get you lower. So I would make my x min. You could make your x min be, I don't know, let's go negative 20 to get us to 1950. And our x max, we're going to find out in a little while what we need to make it be. But it's going to repeat every 4. We could make it be, find the minimum and maximum rodents in, and the years in which they occurred in the first cycle. So I'm going to go, 8 would give me 2 cycles, sure. If you want to just limit it to the, if you like literally only want to see the first cycle, you could put 4 and 0 to 4 and it would just squish you, right? Maybe I'm going to do that. I'm going to make it go 0 to 4 just for this question because it wants it in the first cycle, right? Then all I'm seeing is the first cycle and then all I can give is the questions in which it's asking. And then your x scale could be 1. What mode must I be in? Because this is a word problem. Radians. You can make it be 1. If you make it be 0.5, you just see more ticks, you know? Up to you. If it looks weird, you might be in degree mode. Also, if it looks weird, you might also just have typed it in wrong. So if it's a straight line, watch, you might not have put a variable. It might just be like doing like a straight line, right? You might have not put the variable into your equation. I use the alpha y equals enter button to show the actual fraction, so I have less work. If you're getting a straight line, you're probably in degree mode. Watch yourselves. Is everyone at least getting it to show up? So let's find the maximum. Second, trace, max. You see how it's better to make an appropriate window than just randomly guess and hope you can see it? That's never a good situation. That was me in high school. It's not good. I suck at windows. So it's at, the maximum's at what? 1, comma, 1,500. What the heck does that mean? There are 1,500 rodents in 1970 what? 1. Because 0 is 1970, 1 would be 1971. So there's 1,500 rodents in 1971. That's my maximum. Then I go to my minimum and I go second, trace, min. Well, why did I make my Y-min 900? I should have made it be 800. I think I said 800 then wrote 900. Mine's just touching. It still works, but I like seeing above and below. What'd you get? Something in 900. What'd you get? 3 in 900. So what does that mean? There are 900 rodents in 19, what? 73. 3 years after 1950. And what was the period of this function? We already figured it out. For what? Years. Okay, how many rodents in 2010? It should be between 900 and 1600, should it not? Because I min out at 900, I max out at 1600. So if you have something else, something's wrong. So I need the year 2010. What is that? T equals 40. So there's 2 ways we can do this. If you have your calculator sitting in front of you, if you do this, now pay attention. If you go second, trace, number 1, that's value. It lets you put an x value in, right? And our x value is 40. Put it in and it's going to get mad at you. Oh my goodness. Did it work for you?
Oh, it's because is it because our windows?
Yes, it should get mad at you unless you have someone whose window's red. It's going to get angry at you because my window currently is set maxing at 4. My x max is 4, right? And it's like, I can't find that. You didn't give me enough window. So if you're going second trace value 40 and you're trying to put in x equals 40, but your window max is at 4, it's going to get mad, isn't it? So I need to go to my window and I need to make my x max be at least what? 40. I'm going to go 45 because I'm a rebel without a cause, obviously. So then I go second trace value. And we're going to see a whole bunch of these happening, right? 10 to be exact, because every 4 years it's cycling. And I go 40, and I get 1,200 rodents. Now, what happens if I said algebraically behind this and you do this? Zip, zero, zilch, the big O, you get nothing. Good, you use your calculator. High five, you didn't algebraically do anything. So, algebraically would be out. You would at minimum have to show the equation with this in for x, correct? So, we could go r of 40 equals 1,200 plus 300 sine 40 pi divided by 2. And then you would get 1,200. The reason why, I'll show you. You can even do some math without your calculator. Plus 300. This will be sine of 20 pi. Let's think about that. It's going to get free. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 12 pi, 13, 14, 15, 16, 17, 18, 19, 20. I land here. What's sine of 20 pi? What's y at 20 pi? 0. So this becomes, give me a blue marker. This becomes 0, correct? And what's 300 times 0? 0. 1,200. You didn't need your calculator, you just got big brains. And if this is a written response, would just writing r of 40 equals 1,200 suffice? No, you need a sentence, sadly. So how many rodents could be expected in 2010? In 2010, we could expect 1,200 rodents. Yeah.
You don't add Like the 1200 plus 1600?
So the 300, this sine 20 pi is actually just 0, right? And then 300 times 0 is 0. So let me just get 1200. I shouldn't have skipped that. Okay, we're going to flip back a page. One page back. Gone without an equation. A favorite. I could gift it to people. I would. It's so much fun. All right. A Ferris wheel. Oh, we have a Ferris wheel question again. So much fun. So excited. Okay. First thing I would do is sketch it. Second thing I would do is actually draw the Ferris wheel above the ground, even though I drew the ground level low. And this frustrates me, and I forgot to change it. So if you see the Ferris wheel, it's not above the ground. Stupid. I can't even get rid of that. We'll pretend there's a base on the Ferris wheel. It's not going to be, you know how I drew it perfectly last time where it like lined up with bottom and top? This one, I drew the circle the same. Yeah. Poo. All right. So when I draw a Ferris wheel or any type of wheel, I cut it into 4s, put my little center there. It's not, just pretend that's perfectly in the center. I believe you can pretend. Okay. A Ferris wheel has a radius of 10. What did we say the radius was the same as? Amplitude. So we know right off the beginning of this, we have an amplitude equal to 10. Then if I want to draw it, this is going to be 10 and 10. I don't care about the horizontal ones, so don't worry about those radius. 10 and 10. Okay? It rotates every 40 seconds. So one rotation every 40 seconds, what did I give you? The period. So right away, I can go ahead and plot dots with time. So look here. So this, if it repeats in 40 seconds, that would mean I have 0 seconds here and some sort of height, and 40 seconds here and some sort of height. We agree? And then what time would this one hit? Up top? 20 seconds. So if I want to actually find all the times, what did I just divide the period by last time? Do you remember? 4. So if I go 40 seconds divided by 4, each of these spots where they stop is going to be 10 seconds, correct? So I'm going to hit the midline. This is the midline, remember? The center of your circle is just the midline. I'm going to hit that at 10 seconds. Then I'm going to hit the top at 20 seconds. Then I'm going to hit the midline again at 30 seconds. And then I'm going to hit the bottom at 40 seconds. Do we agree? 0, 10, 20, 30, 40. Okay. Let's read what else to give us. Passengers get on at the bottom. Thank you. Not that scary. You just drop them in from somewhere. Which is 1 meter above the ground. So this here is 1. Right? So what's the height of this coordinate? 1. We agree? What's the height of the midline? 11. You're right. So remember, this is my midline. I'm just going to write that there for my little brain to remember it. So the center of the circle is the midline, right? How long is it up here? 1, 10, 10, 21. What about this height again? Back down to 11. So I want to just do a quick sketch. So this is going to be 1 meter. Isn't going to be perfectly drawn because I need to up the circle and I forgot to. 11 meters. And then 21 meters. 0 seconds. 10 seconds. 20 seconds. 30 seconds. 40 seconds. You know how we just made 4 equations out of one graph just earlier today? Remember how we did that in the quiz? We can do this once we have this sketch. We can do that very easily. Okay, so we have 0, 1, 10, 11, 20, 21, 30, 11, 40, and 1. If you take the time to graph it, which I know is time consuming, it will be much easier to make your equations. Now you're going to write your equations below B here. I just want to keep this on the screen, so I'm going to write my equations down here. But please put yours like where it says write an equation. I just don't want to run out of space. So you're going to draw it below B. So how many equations could we come up with? 4. If I had a choice, which one am I picking? Cos? Which cos? Negative cos. What's on the y-axis? The minimum's on the y-axis. It would have no horizontal shift. So if I'm picking one, I'm picking negative cos. But I'm not allowing you that. You're welcome. I'm going to make you find all 4 because I'm kind like that. It's a gift. You all get it. Okay. So let's give back a gift. It's a gift. But if it were me and I were choosing, I would choose negative cos because I have no horizontal shift. Do you see that? Yes. That would be where I go. Okay. What's my amplitude? 10 because amplitude, radius, same thing, right? So I'm going to go plus 10, minus 10, plus 10, minus 10. Why am I doing this? So I can get all 4 equations. Yeah. Sine, sine, cos, cos. What comes next in my equation? The b value. The b value comes from the period. Period and b value not the same, or it would be a period, which it's not. So don't say they're the same. So what is the period of this one? It was 40. So b equals 2 pi divided by... Why am I using 2 pi? Why can't I use 360? It's a word equation, and when it's a word problem, I have to do it in radians. I do not have an option. Degrees does not make sense. So it's 2 pi divided by 40. So it's pi over 20. Then I'm going to just do these after. How do I get my midline? Yeah. What's the midline? Yeah. Max plus min divided by 2. Yep. What else? Off of here, how can I find it real quickly? So I can count down. 10. Count up. 10. I also labeled it. It's the center of the circle. Remember? Center of your circle is your midline. So you forget all of that, though. It doesn't matter. Max plus min divided by 2 will always get you your midline. If you have the max and you have the min, you have your midline. If you have the max, you have the min, you have your amplitude, right? No knowledge and base needed. Use your formulas. The d value is your average, so you add them. The amplitude is subtract with an absolute value. Okay, so we know it is 11. Okay, we said negative cos was good, x. Yay, done. Right? If I had a choice, that's what I'm picking. Because my minimum is on here. Where does my maximum hit? I'm going to do positive cos next. Where's the maximum happen at? At 20 seconds to the right. So it's going to be x minus 20. For sines, what did I tell you need to draw? Your midline. That's it. I agree. And then it's happening, our intersections, right? Now, do they have to use 30? No, they could end up actually coming over here and using negative 10 would hit again, right? If I kept... hit there. So they could use negative 10 as an option if they want. Okay, so this one's going up. This one's going down. This one's for positive sign. It's happening 10 to the right, so minus 10. This one is negative sign. It's happening at 30 to the right. Okay, we're rebels without a cause. We're going to try all of these. So you're going to go change your window. What are we going to change our window to? I'm going to make my window fit this window. What's this window? 0 to 21 or a little higher for my y. And what's my x? 0 to 40. And I should be able to look at these and see if I actually got all the right equations, because it should graph that, shouldn't it? So go to your window and go 0, your x max 40, your x scale 10s, your y min 0, your y max 21 or 22. I'll go by ones, whatever. Then I go to my y equals and I type in 4 equations and hopefully I see one graph. What mode do I need to be in? Radian. Now remember, to put in the pi over 20, if you have the new calculators, you can go alpha y equals enter and they'll pop up a fraction, right? So you can go 10 sine, a bracket will open up, and then go alpha y equals enter, the alpha button, the y equals button, the enter button, and you get pi over 20. You can put that in as an actual fraction. Then you press graph. Is everyone getting the same graph? Probably still typing. Type faster. Just kidding. Yeah. Yes. You should only see one graph being drawn over top of each other each time, right? Now, if you have the older calculators, if you don't have the ones with color, you can go to Y2 and arrow all the way over to the slash. So you could go over to Y2 if you have the older ones. There's a slash here. So in Y2, you go over to the slash. Doesn't matter if I bring my calculator up because it's colored, it doesn't show you this. You have a slash over there. If you hit enter once, it'll make the slash thicker. So at the very least, you'll see 2 graphs being drawn. It'll draw a thin graph, and then it'll draw the thick one over top of it, and you know you have it going. It's the only option you have if you don't have the colored ones. Okay? What if I ask for an appropriate range? What would an appropriate range be for this? What would I get for an appropriate range of this Ferris wheel? 1 to 21. Now this is the catch. up here it doesn't say, but like in the previous equations when we use h of t, let's say for height, for y, you'd have to use h of t for your equation as well. But we're going to go y such that 1 is less than or equal to y is less than or equal to 21 yer, and that's in set notation, or 1 to 21 in interval. What would be an appropriate domain? Let's think about it. X is what? X is time, right? Can we go negative time on the Ferris wheel? No, we can start at 0 or go up. How do we represent that?
It's greater than or equal to 0.
X such that X is greater than or equal to 0. XCR. And you have to watch on those other ones. If the variable is t, you have to go t such that t is greater than or equal to 0, TER, because you don't even have an X in it. And then we'd go 0 to infinity. Write those down. Number 276, number 6, 9, 12, and 19. We're done chapter 5. We move on to chapter 6 tomorrow. If you have questions with your calculator, you can always call me over. I can help you.
I'm sorry.